America's airport managers and engineers face many difficult tasks today. In an environment of declining revenues and increasing costs, perhaps the most difficult task is to ensure that each dollar spent will produce the most cost-effective benefit. In 1989, Houston Intercontinental Airport was faced with just such a problem. Runway 14 right, 32 left was showing all the typical signs of distress expected of 7-year-old asphalt: oxidation, loss of fines, hairline cracking, and brittle hardened asphalt binder. A decision had to be made: overlay and regroove, or recondition the pavement with the Rejuvenator PDC. Houston's engineers were faced with the following concerns: improve the condition of the runway pavement, extend the pavement's useful life, minimize the downtime, AIP fundability, and cost. The engineers at Houston knew that rejuvenators were designed to improve the condition and extend the life of asphalt pavement. They were also aware the United States Air Force, in conjunction with the Army Corps of Engineers and other independent testing agencies, had conducted tests to evaluate asphalt pavement rejuvenators. The test results were clear. PDC was the single best rejuvenator available. It was the judgment of the testing engineers that a reduction in viscosity, or in plain language, a reduction in brittleness, was the best indication of asphalt pavement rejuvenation. The Air Force applied PDC to numerous asphalt pavements and then performed viscosity tests, comparing treated and untreated pavement results. These tests showed that PDC reduced viscosity by an average of 70%, equating to very real improvements in the pavement's condition. Follow-up tests were then made to see if these improvements were long-term. 3 years after the initial application of PDC, viscosity levels were again measured. As expected, viscosity levels increased in both the untreated and treated pavements. But note this very important difference. While the average viscosity value for the untreated pavement continued to rise beyond the original test level, the average PDC-treated viscosity value remained 37% below the original viscosity level. The Air Force also reported that 3 years after the PDC application, a visual inspection was performed. The PDC-treated pavements showed fewer cracks of 1/4 inch or greater and fewer lost fines when compared to the untreated pavements. PDC is applied in a one-pass application. Airport managers can have their runways, taxiways, and ramps back in service in 24 hours. In today's environment of rising costs, PDC offers 2 distinct advantages. First, PDC has been approved by the FAA for AIP funding. Second, as you are undoubtedly aware, recent changes in the law require that airports implement effective preventive maintenance programs in order to be eligible for AIP funds. Because PDC is the single best preventive maintenance tool available today to improve, protect, and extend your asphalt pavement's useful life, it can help ensure your FAA-required preventive maintenance program will qualify your airport for future AIP funds. Airport managers and engineers often use a tool called a Pavement Condition Index, or PCI graph, to aid them in determining such things as the current condition of their pavements, the predicted remaining useful life of those pavements, and the need to do preventive maintenance. Typical airport PCIs reveal that a pavement will drop out of the very good range in 2 to 4 years, fall into the fair to poor range in 5 to 8 years, and deteriorate to a failed condition in 10 to 12 years. Runway reconstruction or overlay and regrooving at the 10 to 12-year point will most likely be required if little or no interim preventive maintenance is performed. The cost to overlay and regroove to FAA specifications can average $10 to $12 per square yard. If instead the pavement is maintained in the good to very good range through periodic rejuvenation with PDC, significant cost savings can be gained and downtime can be minimized. It is important to note, as illustrated in this PCI, that rejuvenating with PDC does more than simply arrest deterioration of the pavement. As the Air Force found, it actually reverses the effects of aging by lowering the pavement's viscosity, thus making it perform more like new asphalt. In the end, the managers and engineers at Houston chose to rejuvenate runway 14 right, 32 left with PDC. PDC improved the condition of the pavement, extended the pavement's useful life, minimized downtime, all at a fraction of the cost of new asphalt. After the successful rejuvenation of runway 14 right, 32 left, the engineers at Houston specified PDC to rejuvenate their 2 remaining major runways and numerous taxiways. To date, Houston Intercontinental Airport has used PDC to improve and protect over 6,500,000 square feet of asphalt pavement. These aerial photographs demonstrate beyond words that a PDC-treated pavement not only performs like new pavement, but looks like new pavement. As you can see, PDC is a proven rejuvenator that will improve the condition and extend the life of an asphalt pavement. But PDC offers a second valuable benefit. If an engineer chooses to rejuvenate an asphalt pavement with PDC, one way to spec material is by using the FAA's Engineering Brief Number 44, which contains the generic specification for PDC. As shown here, Engineering Brief 44 describes a coal tar sealer rejuvenator. PDC is both a sealer and a rejuvenator, and therefore can also be specified to seal a pavement and protect against damage from fuel and oil spills. The important point is, whether PDC is specified as a rejuvenator or a sealer, the pavement receives both benefits. The engineers at Florida's Department of Transportation were intrigued by this concept, a product that could penetrate into the pavement, improve the pavement's condition, and at the same time provide fuel and oil spill protection. They were all too familiar with the history of emulsion sealed coats and the inevitable cracking and peeling these treatments caused. The quote shown here clearly illustrates the level of frustration within the Florida Department of Transportation and elsewhere. The problem has become so severe that the Florida Aviation Office has taken the general position of not recommending the application of coal tar emulsions or seal coats. The Florida Department of Transportation knew that PDC was neither an emulsion nor a coating. Instead, PDC penetrates into the pavement to become an integral part of the asphalt. Because of this unique difference, PDC does not chip, peel, flake, or delaminate. Florida welcomed the opportunity to put PDC to the test and chose Dunellen Airport in Central Florida as the application site. The ramp and taxiway pictured here were treated with PDC. Not only were the treated pavements protected against fuel spill damage, but tests conducted by the state of Florida on the PDC-treated pavement showed a 61% reduction in viscosity. The PDC demonstration project was reported in the state's Florida Flyer magazine, and here's what a senior engineer for the Department of Transportation had to say. The color was restored to the apron and taxiway, and renewed resilience and flexibility were observed. The effects to the old taxiway were remarkable. Binder material in the pavement that had lost its binding quality was rejuvenated and began to again bind the aggregate. The Dunellen test proved that PDC is clearly very different from conventional surface treatments due to its proven ability to penetrate, improve, and protect. In the 5 years following the first commercial airport application of PDC at Houston Intercontinental, PDC has established a 100% success rate. The manufacturers and distributors of PDC stand behind every job with a performance guarantee. PDC has been applied on runways, taxiways, and aprons at 56 airports around the country and has helped to improve and protect over 24,300,000 square feet of airfield pavement. Airport managers and engineers are discovering PDC is the most effective preventive maintenance tool available today to improve, protect, and extend the life of asphalt pavement. PDC has proven its ability to rejuvenate and protect airfield pavements. But there is another side to the story. Since 1984, PDC has been successfully applied on over 58,540,000 square feet of commercial and industrial asphalt pavement. Today, PDC is protecting a wide range of pavements, from parking facilities at shopping malls, apartment complexes, country clubs, and hotels, to Disney World, to industrial ramps, to city streets. Although specifications for asphalt pavements vary widely depending on climate and intended use, PDC can improve and protect any of the various types of asphalt pavement because of the unique way in which it works. As you have seen illustrated, PDC penetrates into the pavement to replace depleted oils in the asphalt binder. The oils in PDC then rejuvenate the pavement and provide fuel spill protection through the full range of penetration. The appearance of a commercial or industrial property is oftentimes as important as improved condition or fuel spill protection. The chipping, peeling, flaking, and delamination that are so often associated with conventional emulsion surface treatments are ugly reminders of a surface treatment's ineffectiveness. Because PDC is a penetrating sealer and rejuvenator, it does not lay on the surface. Instead, PDC becomes an integral part of the pavement. This not only makes PDC pavement beneficial, but is the reason PDC will not chip, peel, flake, or delaminate. Like airfield managers, commercial and industrial property managers have turned to PDC to improve the performance and appearance of their asphalt pavements. Although these pictures cannot show the improved condition of these asphalt pavements, the improved appearance is unmistakable.